Hi all, I welcome you all to the third part of Module 5. Today we'll be discussing on the topic plane motion of rigid body. So just before starting the session, a general comment. In one of the previous videos, it was commented from your side that if notes are available, then it would be very helpful. Actually, this video itself is the note. So refer the video and write the note. Then also you will be having a suggestion. If notes are available, then it is easy to copy down instead of referring to video each time. But what I suggest is don't just copy the notes from video. For better understanding, what you have to do is initially refer the video, by heart the formulas if any, understand the concepts and see one question at a time and see how it is solved. After that, write the question in your note, solve it on your own. If you have any doubt while solving, refer the video and clear it. By doing this after a video lecture, you will be thorough with the concepts and will be able to do any type of problem from that portion. So better learn in this pattern. Also for sure, you will be getting notes from your college, but consider this video as your additional notes. Write it somewhere in your notes or keep an additional book for solving these additional questions. In the case of mechanics, we don't know which type of problem will be coming, so try to solve as many problems as you can. Normally, we don't like anyone advising us, so don't take it as an advice. Just consider it as a suggestion for the betterment of your engineer mechanics. Okay, now let us start our topic. So in the initial part, we have seen that there were three types of motion. First is translation, second is rotation. It was discussed in the last two parts about rotation. So in this part, it is the third type of motion, which is combined motion of translation and rotation. So from the name itself, you will be getting an idea. It is a combination of translation as well as rotation, or we can, in common generally say it as general plane motion. So that's your heading: general plane motion or plane motion of rigid bodies, or it can be said as combined motion of translation and rotation. So general plane motion means any plane motion which is neither translation nor rotation alone. It is neither translation alone nor rotation alone, then it is general plane motion. It is a combination of translation as well as rotation. Now consider this figure itself. This is a link AB. Link means it may be either a rod or a stick. So consider a link AB which moves from initial position AB to A1 B1. So initial position is AB. It moves to A1 B1. Here we cannot say it as a purely translatory motion. If it is translatory motion, it would be moving in a parallel plane. Both would be moving in a parallel plane. Nor it can be said as a motion of rotation alone. If it is rotation, it will be rotating about any fixed points. But in this case, it has moved from A to A1, while it has moved from B to B1. Both the distances are different. So let us see how to combine this as a translation and rotatory motion. So initially it is AB. Here it is shown. Initially it is AB. Let us initially assume that it has moved translatory motion. So which means it has moved from A to A1 and B to B dash. A to A1 and B to B dash. This is parallel. This is also parallel. It has moved the same distance. So AB to A1 B dash is translatory motion. And after that, it rotated about the fixed point A1 and it rotated from B dash to B1. So keeping A1 as fixed, it rotated from B dash to B1, which means now it has moved from AB to A1 B1. The same thing is applied over here also. Initially it is translation, then it is rotation, which is a combined motion of translation or rotation, or it is a general plane motion. Now let us see some examples, then it will be more clear. The first example is a bar sliding against a wall at one end and floor at the other end. It may be a bar or a stick or a rod or a ladder. It may be anything like that. So initially the position was A1, B1, shown in red lines. It is A1, B1. Now it is kept against a wall and a floor. Now it is sliding from this position to this position. So initial position is A1, B1. Final position is A2, B2. Now how can we say this as a combined motion of translation and rotation? So what we do is This is the initial position A1 B1. So it is shown over here also A1 B1. Now we are assuming that it has moved translation alone, which means it has moved from A1 to A2, while B1 has moved from B1 to B1 dash B1 star. So this is moving same distance and it is parallel. So it is motion of translation. Now in the second case, assume that from A to B1 dash, this is the second case, first position. It by keeping A2 as fixed, it has rotated from B1 star to B2. So this is pure rotation alone. Keeping A2 as fixed, it has rotated from B1 star to B2. Now it has reached the final position, which is our A2 B2, which is shown over here also. So this is a combination of translation as well as rotation. I hope it is clear to you. Similarly, let us see one more problem. Motion of a roller without slipping. So motion of a roller means what do you normally see in your vehicles? Wheels. Consider that wheel itself. If it has moved from one point to another point, we can say it is not rotation alone. If it is rotation means it will be rotating about this point itself. It will be rotating like this. But consider the motion of a vehicle, that is the motion of a wheel. It will be moving from one point to the another point, which means this B1 distance might have moved after rotating to a point B2. So it can't be said as a motion of translation also, translation alone. If it is translation alone, then B1 will be here also. If here it is B1, here also it will be B1. But instead it has translated as well as rotated. That is, linear motion is there as well as a rotation is there. So let us see how it is done. So the initial position is C1 B1. Now consider it as a translatory motion, which means it has C1 has moved to C2, B1 has moved to B1 star. So this is purely translation. The distance is same, it is parallel, so it is translatory motion. Now in the second case, assume that from C to B1 star, this is C to B1 star, the final position of last one. So it is C to B1 star. It has rotated about the fixed point C2 to a new position from B1 star to B2. So from B1 star to B2, it has rotated like this, keeping C2 as fixed. Now what happened? Now we can see that from C1 B1 it has moved to C2 B2, which is done over here also. C1 B1 it has moved to C2 B2. So this motion of roller without slipping also can be considered as a general plane motion. This without slipping is important because if it is with slipping or skidding, it means it is purely translation only. So if it is without slipping only, then it will be rotated as well as translated. Now we will be doing problems on these two examples. Let us solve a problem on the second example initially, because this is more important and many problems can be done on this motion of roller without slipping. Okay, just before starting the problem, let us see what all are the concepts in this problem. So if you understood this page, then you can do any type of problem related to this. So clearly understand it. So consider a roller. This is a roller. The center point is C. Assume that it is moving towards right. This roller is moving towards right. So center point is C. So let VC be the velocity of the center point. Or we can say that VC is the velocity of the combined of the whole roller. Now, if you want the velocity at any other point in the roller, then how to do it? So if it is any other point, we will be saying it with respect to the center point itself, which means consider this as A, B, D, E. Consider initially first these 4 points. So if you want to find the velocity at this point, we will be saying it with respect to the center point C, which means this is the velocity of A with respect to C, which is represented by VAC. So this can be written in many ways. It is either VAC or it can be written as VA bar C. Anyway, we have represented this notation itself VAC, which means velocity of A with respect to C. And it is also to be noted that this velocity will be perpendicular to this AC. This moment or motion or velocity will be perpendicular to the line connecting A and C, which means it is 90 degree. Similar is the case with other things also. This is B point, this is C point. If it has to be moved forward, then this point B will be moving in the downward direction. Just imagine that the motion of a vehicle. If it is moving towards right at a particular instant, this will be moving towards right. This point will be moving downwards. This point will be moving towards left, and this E point will be moving upwards, isn't it? Then only it will be moving in the forward direction. Or just assume that this at this T point, instead of this is going to the left, assume that this velocity of DC is going towards right. Then what happens? Velocity of AC is also towards right, velocity of DC is also towards right, which means that rotation will not be taking place, it will be only translation. So in order to happen in a general motion, it should be like this. At A point, it will be moving towards right. At B point, it will be moving downwards, which means it is perpendicular to the BC point. And at point D, it will be moving towards left, and it is perpendicular to DC. At point E, it is moving the upward direction, and it is perpendicular to EC. So at any point, we can say that if you are taking the velocity, it will be perpendicular to the line connecting the center point and that particular point. So that is about A, B, D. Similarly, consider the other points also. If it is in between A and B, it is, let the point be F. So the velocity will be like this. This is going in this manner with an inclination. Then this velocity of FC will be perpendicular to the line connecting C and F. Will be perpendicular to C and F. Similar is the case with velocity of GC also, it is perpendicular to GC. Velocity of HC perpendicular to HC. Velocity of IC perpendicular to IC. And there is only a single formula to find it. To find the velocity, velocity is given by V equal to R omega, where V is the linear velocity, omega is the angular velocity, R is the radius. In this case, all the points are on the circumference, so we can say it as the radius itself. Or if it is in between, if it is not on the circumference, just assume that this point A is not on the circumference, so it is somewhere over here. So we can't say it as radius, so it is better to say in terms of this distance itself, which means if velocity is over here, assume A is over here, then it is better to say velocity of AC equal to, instead of R omega, better to say it as AC into omega. So velocity of BC will be BC into omega. Instead of R, it is represented by that distance. Velocity of DC is DC into omega, and velocity of EC is EC into omega. Similar is the case with other things also. For example, velocity of FC is FC into omega. The only thing to be noted is this FC and velocity will be perpendicular, and only this equation to be used. So that is the velocity of a point with respect to the center. But what we want is the velocity at this point itself, which means what is the velocity of A, what is the velocity of B, D, E, etc. What we said is velocity of a point with respect to the center. What we want is the velocity at that particular point only. So again, consider the same figure. We have drawn only a few velocities over here. So consider it. Velocity at C, at point C, it is VC itself. At A is velocity of AC, velocity of BC, velocity of DC, and velocity of EC. These all things we have already said, and consider this velocity of FC also. All will be perpendicular. And assume that the CF is inclined at 30 degree. Now, how to find the velocity at a particular point A? Initially, we will be writing it as a vector sum. Vector sum means we know this velocity is a vector, which means it has magnitude as well as direction. So we will be representing it initially in vector addition. So velocity of A, this is what we require. It is not AC what we require the velocity at the point A. So vector A equal to vector C plus vector A with respect to C, which means if you want to calculate the velocity of this point, then it should be told in terms of the center point itself. So velocity of A equal to velocity of center point plus velocity of A with respect to C. Now, if we are avoiding the vector representation, that is if you are considering the direction, what is the velocity at point A? Now we'll be considering C point and A point only. So the velocity of C point is towards right. Velocity of AC is also towards right, which means at point A, that is velocity of A will be the summation of velocity of C and velocity of A with respect to C. Velocity of C towards right, velocity of AC also towards right. We will make it more clear. Consider the next case, velocity of D. So initially we will be representing in vector itself velocity of D, vector velocity of vector addition of VD equal to velocity of C plus velocity of D with respect to C. So what we do is, if you want to find the velocity at a particular point, it is the vector addition of the center point as well as this relative velocity. Now in the next step, we will be calculating it originally, which means velocity at the point D equal to. Now avoid the vector addition. See in which direction it is moving. Velocity of VC towards right, while velocity of DC towards left. So what to do? If you are avoiding the vector addition, then velocity of D point will be VC minus velocity of D with respect to this thing. Now let us see the velocity of D point. So velocity of B point, vector addition of B is, where is B? This is B. So B is velocity of C vector C plus velocity of B with respect to C, that is vector addition. So if you are representing it in the original format, it will be this point B, there is velocity of C which is moving towards right. Point B, well, for considering point B, you will be considering center distance, center velocity, as well as the velocity of the point with respect to the center. So these two terms are to be considered, VC and VBC. The VC is moving towards right, velocity of BC is downwards. So finally the figure is like this. This is towards right and this is downwards. Now what will be the velocity of B? It will be the resultant of these two things, just like what we have seen over here. Here velocity of A is the resultant of VC and VAC, which is addition. Here velocity of D is the resultant of VC and VDC, which is subtraction. Here the resultant of VB is here VB is the resultant of these two values. So one is horizontal and one is vertical. How to find the resultant value? We have seen it in first module. Resultant VB equal to root of VC square plus VB square. Similarly, if it is at the point E, there will be two velocities. The vector addition is like this: VE equal to VC plus VEC. This is vector addition only. So VE equal to, at point E, VEC is upwards, VC is towards right. So it is like this. The total velocity VE will be equal to the resultant of VC and VEC, which is root of VC square plus VE square. So this is just vector representation only. Don't misunderstand it. Or if you have any confusion, then you can avoid this step also, and then you should be writing it directly. So anyway, we will be explaining in this manner itself, vector addition, and after that we will be saying in which direction it is moving. So that is the case with A, B, D, and E. Now if it is inclined at 30 degree, then how to do it? It's not only 30 degree, if it is inclined at any angle, how to do it? So what we told is this VFC will be perpendicular to FC, which means this is 90 degree and this is 30 degree. So let us see it one more time. This is C point, velocity of C is VC is towards right, it is making an angle 30 degree. This is VFC, it is perpendicular. Now again, we want to see what is the inclination of this VFC with respect to horizontal. With respect to horizontal, what is the inclination? So in order to solve that, let we extend this line. This is 30 degree with itself with respect to horizontal. As this is 30 degree with horizontal, this will be 30 degree. Now this line and VFC will be perpendicular. As this is perpendicular, this is also perpendicular, which means VFC will be inclined at 60 degree with respect to horizontal. So if VFC is inclined at 60 degree with respect to horizontal, then we have to resolve in horizontal direction as well as vertical direction. So it is in the horizontal direction, it is VFC cos 60, and in the vertical direction it is VFC sin 60. So we will be resolving this thing into horizontal as well as vertical direction. Now to find the velocity at the point F. So what we do is, for the inclination case, it will be like this. There will be x direction as well as y direction. So velocity of f in x direction. What all are the forces or velocities in x direction? It is vc plus vfc cos 60. Now what is the force in y direction or velocity in y direction? It is vfy equal to vfc sin 60. So what we have finally is like this. Vfx is horizontal, Vfy is vertical. Now how to find Vf? It will be the resultant of these two, which means it is root of Vfx square plus Vfy square. So if you understood this page, then there is nothing to worry about it. So please go through it carefully and understand the concepts. Then let us see the problems. Here, in the before starting this problem, here there's just a small note. So while doing the problem itself, we will be understanding that if this is velocity of C point, we can see that this point, at this point the velocity will be 0, which means velocity Vd will be equal to 0. Velocity of B will be 2 times that of velocity of C. So that all things are written in this note. So it's not necessary. While doing the problems, we can see it. Anyway, the notes written are: the point on the roller in contact with the surface is at rest, which means Vd equal to 0. The point on the top of roller moves with twice the velocity of center. Top of roller means Vb will be 2 times the velocity of C. The velocity of any point on the circumference is the vector sum of the velocity of the roller and relative velocity of that point with respect to the center. So this thing we have already specified, which means Va equal to the vector sum of velocity of roller. Velocity of roller means it is the center velocity Vc plus and the relative velocity of that point with respect to center. So A with respect to C, which is Vac. Similar is the case with B also. So these things we have already said. Now let us see the first problem. A cylinder of radius 2 meter rolls without slipping along a horizontal plane as shown in figure. Find the velocities of points A, B and D on the circumference of the cylinder. The center C has a uniform velocity of 10 meter per second. So what is given? The radius is given, which is 2 meters. Velocity of center point is given as 10 meter per second. This is given in the question itself. This is moving towards right. So we have been asked to find the velocities at A point, B point and D point. So what we have to do is draw the velocity of A with respect to C, and how to draw it? It will be perpendicular to AC. This VAC will be perpendicular to AC. Velocity of BC will be perpendicular to BC. Velocity of DC will be perpendicular to DC. Now we have VC equal to 10 meter per second. What is the relation between V and omega? VC equal to R into omega. Let it be represented by R itself, center point. So VC equal to R is 2. Omega is unknown. From that you will be getting omega, which is 5 radians per second. Now we will be considering each point, which means for finding velocity of point A, it is vector A equal to vector VA equal to, this is vector addition. So vector addition of VA equal to VC plus VAC. As we told earlier, VA will be equal to center point plus A with respect to C. Now we had to see the directions, which means VA equal to, this is at point A, this is horizontal and this will be perpendicular. So it is like this. At point A, VC is horizontal and this is perpendicular. So it will be the resultant of VC and VAC, which is root of, what is VC? It is 10. What is VAC? How to find VAC? As we told earlier, VAC is AC into omega. What is AC distance? AC is the radius, which is 2, into omega. We already got it as 5. So VAC is also 10, which means VA equal to root of VC square plus VAC square. So you'll be getting 14.14. If you want the theta value in between, then it is tan theta equal to opposite side by adjacent side. Opposite side over here is VAC divided by VC. So you'll be getting theta equal to 45 degree. Similarly, the velocity of point B will be at point B. It is vector addition is VC plus VBC. Now the original thing, velocity of B is this VC as well as VBC is going in the same direction. So we have to just add it, which means VC is 10. VBC, how to find VBC? It is BC into omega. In all these values, it will be same. As the radius is same, it will be same itself. VAC will be 10 radians per second. Sorry, this is meter per second, not radians per second. linear velocity. So all these are meter per second, 10 meter per second. VDC is 10 meter per second. So VB is at point B, it is a summation of VC and VBC, which in which you will be getting 20 meter per second. Similarly, at point D, how to find at point D? It is the vector addition of VC and VDC. Now VC is moving towards right and VDC is moving towards left. VDC we already got it as 10 meter per second. VC is 10 meter per second. So it is 10 meter per second towards right, 10 meter per second towards left. So finally you will be getting it as 0. Which means here we can see that as we have written in the note, at point D, that is in contact with the surface, is at rest, which means at point D, this is the point D, it is 0. Now point B, at the top of roller, it is twice the velocity of center, which means VB equal to 2 times VC, which is 20 meter per second. So these things have been written as a note. That's all. Anyway, modify this radians per second as meter per second in all these cases. Next question. Calculate the velocity at a point 2/3 radius from the top point of a rail car. Wheel of radius 250 millimeter if the car moves without slipping on straight rails at 15 meter per second. So radius is given, which is 250 millimeter. Convert into meter. The velocity at center point is given. It is 15 meter per second. Moves without slipping on straight rails at 15 meter per second. So center point is given. Now we have been asked to find the velocity at a point 2/3 radius from the top point of rail car. So from the top, 2/3 radius. This is the radius. From the top, 2 by 3 r. So this is the point B. So velocity is C towards right. Point B also, it will be, velocity BC will be perpendicular to BC. So we have represented over here. This is 2 by 3 r. The remaining will be 1 by 3 r. That is between B and C, it is 1 by 3 r. Now how to find the velocity of B? Vector addition is VC plus VBC, or VC equal to R into omega. BC is known to you 15, R is 0.25, so from that you will be getting omega. Now how to find VBC? It is BC into omega. BC into omega. BC is 1 by 3 R. R value you know, omega value you already got. So you got VBC also. Now how to find the velocity of B? It is both are moving towards right. So just add it. VC plus VBC. VC is 15 plus VBC is 5. You will be getting 20 meter per second. Now next problem. A compound wheel rolls without slipping as shown in figure. The velocity of center is 2 meter per second. That is VC is 2 meter per second. Find the velocities of points A and B. The inner circle is 0.2 meter diameter and the outer circle is 0.4 meter. This is a compound wheel. There are two circles. So at point A and point B, the velocity is to be calculated. So we know the direction of velocity will be like this. It will be perpendicular. VAC will be perpendicular to AC. It will be moving towards right. And at B point, this also VBC is also perpendicular to BC and it will be moving towards left. Okay, what all things are given? Velocity of C is given. Center point is 2 meter per second. Then the inner radius is inner diameter is given as 0.2 meter, so inner radius is 0.1 meter. That means OC distance is 0.1 meter. Outer diameter is 0.4 meter, which means AC radius will be 0.2 meter. Now what all things are to be calculated? Velocity at point A as well as velocity of point B. Anyway, we had to calculate velocity of A with respect to C as well as B with respect to C. How to calculate velocity of A with respect to C? VAC, it is AC into omega. AC distance we know into omega. How to calculate omega? It is to be calculated from this center velocity, which means VC equal to, it is OC into omega, or VC equal to R omega, inner radius itself. So omega will be VC divided by OC, which means omega you will be getting 20 radians per second. Now velocity of AC will be equal to AC into omega. AC distance is known to you. Omega is also known to you. So you will be getting VAC as 4 meter per second. Now velocity at point A will be equal to summation of these two. Since both are in the same direction, velocity of A will be VC plus VAC, which is VC is 2, VAC is 4. So you will be getting 6 meter per second. Similarly, at point B, it is we have to calculate this velocity of BC as well as this VC is given to you. So velocity of BC will be BC into omega. What is BC distance? This is also the outer radius, which means it is 0.2 into omega. Distance is already known to you. You will be getting VBC as 4 meter per second. The velocity of point B will be equal to, this is moving towards right and this is moving towards left. So subtract it. BC minus VBC, you will be getting minus 2 meter per second. What is this minus 2? Minus 2 means means it is moving towards left. If we get positive, it is moving towards right. As this is moving towards right, positive sign means it is moving towards right. Negative sign means it is in the opposite direction to that of motion. So a few more problems are there related to this general plane motion. We can see it in the next part. I hope it is understood to you. As said earlier, again understand the first page which we have explained in detail, showing those figures. If you know it, if you understood it, then there is nothing to worry about it. Okay, thank you.